Hello students. So we were studying class 9th chapter 8, that is motion, and up to part number 4 we have completed. Yes, means half of the portion of the chapter we have completed. Okay, now we are going to discuss something which is very important. Yes, so the first precautions which you should take. Okay, first of all, just listen, don't write anything, just listen. In second attempt you may start writing and you may note them down. Okay, but right now just see and observe. Okay, so here we are going to discuss this particular graphical representation of motion in two part. Okay, now first one will be introduction, means we will see actually what is graph. Okay, and then how in our general life we used to see the things in a graphical form. Okay, then few terminologies which we will use, and from the class 9th onwards you will have these terminologies and you will have increment in these terminologies. Okay, now this will be our introduction portion. Rest, second one, it is more important, that is types of graphs. In this we will discuss the graphs which is there in your course, that is distance time graph, which is also known as position time graph, and in symbolically form that will be ST graph. Okay, and in this we will see two types of motion, that is uniform motion and non-uniform motion. Means for uniform motion we will see distance time graph, for non-uniform motion we will see distance time graph. Okay, then velocity time graph, which we may symbolize as VT graph. Okay, now this thing, okay, velocity time graph, we will have three cases. First one, when the velocity is constant. Then second one means constant velocity. Yes, as we have already discussed about the when will be the velocity constant, and in that case what will be there with the acceleration. Okay, now this will be the zero acceleration case, when uniformly accelerated, and then when non-uniformly accelerated. Why I am not using this uniform motion and that on here, we will see it, okay, at the time, and why only acceleration I have used here, why not in this one. So we will see this. Okay, now so let us begin with our introduction part. Okay, so in this introduction part, the very first thing which we are going to discuss is graph. Okay, so what is graph? Let us see what is graph. Okay, now up to class 8, in class 8 you have already seen, you had a chapter which was time and distance, or distance and time. Okay, now in which you have already seen basic graph like this. Yes, this was the origin. Okay, then this is positive x-axis, then this is positive y-axis. Okay, over which we had measured different thing here, different things here. Okay, now distance time graph. Okay, now in this you had a line graph, you had a bar graph. Yes, these two were the main one. Yes, okay, and then we have already seen that when we may use both these graphs. Okay, now these are the two types of graphs which you have studied. Yes, then pie chart and data, so many different type of graphs are there which is not there. Okay, so we will discuss only this line graph. Okay, bar graph you have already studied. Okay, now okay, so now sir, few more thing, that suppose this is the graph. Okay, now how we got this? Actually this is our Cartesian coordinate system. This is x-axis, this is y-axis, plus x plus y, minus x and minus y. Yes, okay, now so how to represent anything? Okay, suppose I think you have seen the cricket matches. Okay, now suppose two students are there, A and B. Okay, and they are best friend. Okay, now and they both love playing cricket, as well as seeing cricket. Okay, now one such day there was a match and A had seen the full match. Okay, so A spent 3 hours and he had seen each and every shot and wicket. Okay, that if I ask him, then he can explain anything regarding that 3 hours for match. Okay, now after some time B came. Okay, now B did not see anything related to that match. Okay, but yes, he had a graph. He had a graph. Okay, now I had asked a few questions to B, okay, related to that match. Okay, he did not see the match, still he is able to answer that questions. How? So that is nothing but what? That is graph. Suppose. So that graph we usually see such type of graphs used to come, and in between they used to have few balls. These balls are uncertain one. Okay, it depends over the player whether they are performing, how they are performing. Okay, now so this is nothing but what? This run and overs. Okay, in which over or wickets, or okay, wickets, we may better say wickets with run. Okay, because this is nothing but now see. So how, suppose if I asked B, then when the first wicket had fallen down for a particular team. Okay, now A had already seen the match, so A could give the answer in a quite easy way. But yes, B, just by seeing this graph, yes, this is the very first ball, and then in that particular graph, this ball was showing that the falling of wicket. Okay, wicket fallen. Okay, now so this first one, so what he saw, B saw that at this particular place, as this particular line, this axis is for overs. So suppose say here there was a 10. Okay, so what B will say, yes sir, the first wicket was fallen or fell down in 10th over. Yes, now suppose, so this is the wicket, ball means wicket. Now if suppose I ask him that what was the run rate, okay, if I talk about, then he used to see, or he should see over here, yes, run rate according to that. Okay, whatever will be the value. Okay, but yes, in both the cases B saved his 3 hours by not seeing the match, is still able to give the answer as A can do. Yes, so this is the benefits of graph, that you can save your time as well. Okay, you may observe, you may analyze any situation if I give you some graph. Okay, these graphs might be from the first century onwards up to this 20th century. Okay, regarding what? Regarding the development, regarding the different regimes, regarding the different technologies which came year after year. Okay, so you may better answer them. Okay, so this is nothing but what? The how can we understand this graph? Now see, one thing which you can note here, that this thing over the x-axis. Okay, over the x-axis usually we will take the things which are quite constant. Okay, now that thing we will see in this third one. Okay, now let us move ahead. This is nothing but what? This is our basic understanding regarding the graph. Okay, okay. Now second one, general life cases in a graphical form. Now very important one, general life cases in graph. General life cases, let us see. Okay, very simple one. Again we are having two students, that is A and B. Okay, yes, now let me draw few graphs. Okay, now let me take time here and say distance here. Say 1, this is time, this is distance, or any other thing we may take. This is time, and this is distance. Okay, now see, in first at random I am uh, I'm going to make lines. One line I had drawn like this, one line like this, one line like this. Okay. I even do not know what is going there, but yes, we will analyze. Okay. So how can we analyze this? Okay. Suppose this was the distance. Okay. S. Okay. And suppose here the value was 10 kilometer. Okay. And here we had a time in hours. Okay, now this is 1, this is 2, this is 3. Okay, now let us observe the situation, or let us make a particular situation regarding the graph. Okay, now suppose A and B, two students were there. Okay, and last they met, and the day was Saturday. Okay, they had planned something for Sunday. Okay, now A said to B, that I will meet you, yes, at that particular place. Okay, yes, so you have to come and then we will move. Okay, now at that particular place. Okay, now at that particular place means what? They have talked. Okay, now that place is 10 kilometer away from B's house. Okay, according to graph, now we are going according to graph. Okay, so A and B both talked, and A said that we will meet at that particular place, so he got that particular place. Now that place was 10 kilometer from the B's house. Now this B at 10 kilometer from his house, waiting for A. Why waiting for A? Let us see. Now see the graph. This is the distance. This y-axis is distance and x-axis is time. Okay, now see. At 0 means what? When B will move to 10 kilometer, then only that particular situation will start. Yes or no? Yes. If he will be there at his home, then he will say that I got late. Yes. Okay, मैं late हो गया for that particular. But if he is on time, or it depends over the B. Okay, so B at origin, okay, when the time was means just started, or they had decided for 10 or for 10 am, so that 10 am is origin. Yes, we will start from that 10 am. Okay, so at 10 o'clock B had reached 10 kilometer from his house. Okay, now he is waiting. Why he is waiting? Because see the line. Okay, now if at 1 hour, after completing 1 hour, okay, he is at 10. After completing 2 hour, he is at 10. After completing 3 hour, he is at 10. Okay, so what does it mean? It means that B has kept his vehicle at 10 kilometer and waiting for A. A still did not come. 1 hour passed, 2 hour passed, 3 hour passed. A still did not come. Are you getting this? So this is the basic graph, that when something, okay, which is at stationary position. See 10 kilometer, that was the initial one. After that means we do not know. At origin we was not there, or we were not there, but after, when we had reached at 10 kilometer, after that we had started observing the situation, and then 1 hour, 2 hour and 3 hour. So we may say this is nothing but what? In this case, the object is at rest. Object is at rest. Now see, this rest, every time, sir, this will be rest? No, it depends over whether this physical quantity, everything will be depending over this and this physical quantity, what these physical quantities are. Here this is distance, and if this is a horizontal line, then no distance is covered further, so that particular object is at rest. Yes. Okay, so this was the first situation. Okay, still the A did not come, so they did not move. Okay, now the second situation, same situation, we are putting in some another. Okay, now see here again we are having some distances. Okay, now this time what? This time we got the thing that A have a problem of forgetting the things. Say Okay, so this is 1 hour, this is 2 hours, this is 3 hours. They are in hours. Okay, now this is 10 kilometer, this is 20 kilometer, this is 30 kilometer. Okay, now up to 30 kilometer, same. Okay, now which type of situation is this? Can you guess? Suppose this is distance and this is in kilometer. Now this time, see the scenario that they had already talked, we don't know. Okay, and they had started early at whatever they have decided. Suppose they had decided 10 a.m. Okay, so from 10 a.m. they had started their journey. Okay, they might be in a single bike or a double bike, no problem at all. But yes, after 1 hour they had completed 10 kilometer. After 2 hours they had completed 20 kilometer. After 3 hours they had completed 30 kilometer. What does it mean? In first 1 hour they had completed 10 kilometer. In second 1 hour they had completed further 10 kilometer. In third 3 minus 2. In third means again 1 hour. So in third hour means that is also 1 hour. Okay, in third hour again 30 minus 20, 10 kilometer. Again they had completed 10 kilometer. So what does it mean? It means after a particular interval of time, yes, time interval same, distance covered same, yes. So equal distance in equal interval of time, as we have already seen. Which type of case will be there? This is what? Uniform motion. So object is performing uniform motion. Okay, now suppose the graph is like this. Okay, this might be okay, that will we will see the later on. Okay, now so this is the second case situation, we got it. Yes. Okay, so object is moving with the uniform motion. Okay, now see one more situation is there. In this situation again we will have our measurements. Okay, that is what? This is 10 kilometer, this is 20 kilometer, this is 30, 40, 50. Now see, here we have to see at this particular one. Suppose at 1 hour, this is 1 hour, say this is 2 hour, say this is 3, this is 4, and this is 5. Okay, now at 4 we will see like this. Okay, and then at random we are getting the position. Okay, so here we may see that in first 1 hour, yes, how much? Almost half, like 5 kilometer they have covered. He or both, they have covered what? 5 kilometer. In next 1 hour means what? 5 to, then next, okay, again 5 kilometer, no problem. Then 2 to 3, again next 1 hour 10 kilometer. So here 5 kilometer, here also 5 kilometer, here they had covered 10 kilometer. Then next 3 to 4. Now 3 to 4 means what? This is more than 30. Yes, more than 30 means what? This is 10 and say this is 14. Okay, this is 4. 10 plus 4, 14. Okay, now so we may say, or we may see that after every equal interval, 0 to 1, 1 hour, 5 kilometer, 1 to 2 again 1 hour, 5 kilometer, 2 to 3, again 1 hour, 10 kilometer. Yes, means after first hour completed 5, after second hour means 5, again after third hour means hour means what? Ultimately what? 1 hour is there, na? Third hour is also 1 hour. Okay, so 1 hour 10 kilometer, and last 1 hour 14 kilometer. So it is not a pattern. Yes, the pattern is quite not in a uniform form. Okay, so you may say that they were moving. Yes sir, they were moving, but they were increasing their speed, decreasing their speed accordingly. Okay, because in first hour only 5 kilometer, in second hour only 5 kilometer, in third hour 10 kilometer, in fourth hour 14 kilometer. Yes, so that was what? That was a non-uniform motion, in which in non-uniform motion where time was same. Okay, but distance covered was different. Yes, if distance covered was different, what does it mean? Yes, that speed was varying. Yes, so they were performing non-uniform motion. Which type of motion? Non-uniform motion. Remember, very important, these are the three cases which we will use them further. Okay, so this was the part in which we have seen the general life condition. Yes, over the graph. Okay, so this was the second one. Okay, then next one, last one, in which we are going to see the different terminologies regarding the graph. Okay, regarding the graph, different terminologies in which the basic terminology, one is what? Constant, which we have already seen. Constant graph. Constant graph. Okay, constant graph means what? Okay, suppose we are having is x-axis and a y-axis. Okay, now before this, okay, one more thing which is to be remembered. Okay, that always, yes, always take time, that is t, on x axis. Always take time on x-axis. Why, sir? Because over this x-axis, because time is what? Yes, once it has passed, it never come back. Okay, so in this particular case, yes, every time you will move further. Yes, you cannot move reverse because time never come back or never reverse. Okay, it always moves and moves. So remember, this is important one. Okay, that is what always take time on x-axis. Okay, now let us see the constant graph. Constant graph means what? Now, sir, for time we are having a confirmation that it will always move on. Yes, means it will always increase. Suppose this is 1, this is 2, this is 3, and further. Okay, now constant graph means what? Constant graph means what? With respect to this time. Yes, that particular quantity. Yes, that particular quantity having a constant value. Yes, suppose here, yes, whatever this physical quantity is, but yes, here you may say that suppose the position S is here. Okay, now, so suppose position means what? Distance, so constant distance, whatever was the initial 1 hour, so finally the constant one. If I take velocity here, then velocity is constant throughout the motion. Okay, so such type of graph is what? These are known as constant graph. Okay, yes. Okay, then constant graph completed. Then next one is, that is slope. One more important quantity or one more important terminology, that is slope. What is this slope? Okay, slope means what? We have seen, suppose this is the wall and this is the over land area, and then suppose if we put something, yes, like a ladder, then this is nothing but this is the slope. You may sit here and then you may slide over this. So this is nothing but what? This is the slider, and then why it is slider? Because it is having some slope. It is having some slope with this particular one. Yes, with the ground it is having some slope. So we are going to talk about that particular slope. Okay, so that slope is nothing but what? Suppose let us take a graph. Okay, suppose this is the graph. Okay, in which this is the origin, and say the graph is like this. This is the general form. Okay, in general form. Okay, this is the general form. Okay, now see, suppose if I talk about this particular one. Okay, suppose I take a point A here and a point B here. Okay, now with respect to A, I will have here some point, and with respect to B, I will have something here. Okay, now suppose that it is time, so it will be TA and it will be TB. Yes, and here suppose this is the distance, so this will be SA and this will be SB. Yes. Okay. Now this is nothing but what? Again, see, this is sliding portion. So actually this is what? This is the slope. Okay. Yes. Now this is the slope, means, sir. Okay, no problem. This is the slope, but yes, what after that? Yes. So after that, the thing is, we may now say, suppose this is the distance and this is the time. Now suppose someone asks us uh, for finding out the speed of this particular one. Now sir, we are having distance and time only, and how can we find the speed? Now see, let us see. Now how much time that particular object took to move from A to B? If from A to B, yes, how much time? So that will be nothing but what? From origin to TB, and origin to TA. Yes, the portion which is not common is this one. Yes, so how will it be found? So it will be nothing but what? TB minus TA. Yes, so TB minus TA, that is nothing but what? The time taken from moving from A to B, and how much distance they have covered. So again, from origin it is SB, and from origin it is SA. Yes, the non-common portion is this much. How will we find this? So this will be found out by SB minus SA. Yes, so this is the total distance covered, this is the total time taken. Yes, now we know that speed is nothing but what? Distance upon time. That is what? Distance upon time. Yes, of distance upon time. So distance, how much distance they have covered? That is what? Capital S. How much time they have covered? That is what? Small t. And this is what? The speed. So speed will be nothing but what? That is what? SB minus SA upon TB minus TA. Yes. Okay. Now see. Listen carefully. Listen. Speed is equal to distance upon time. That is S upon T. That is SB minus SA upon TB minus TA. Is I have taken these values. Okay. Now see. We may see this is nothing but what? See this one. And now I am going to write with different ink. Okay. Just to match these two ones. Okay. Speed is equals to, here in this particular case, change in y-axis upon change in x-axis. Yes, change in y-axis upon change in x-axis. And change in y-axis upon change in x-axis, we used to say it as slope of that graph. Slope of graph. Okay. Yes. So this is just for the sake of your knowledge. We will see it again. Okay. So this was the third part, in which we have seen few important things. Okay. Few more are there which we will use in between while studying. Okay. So this was the first part, that was the introduction part.